pencil lead, I guess, right?
Well,
or that was the foxhole one.
That was the foxhole one.
All right. Well, I think we're live tonight. Boy, we had trouble last week. Hello, everybody. Welcome to Amateur Radio Roundtable. I'm Tom, W2VU, and we've got a good show for you tonight, I think. Actually, it's a show we were supposed to have last week, but things went bad last week. We've upgraded our software. We figured out what YouTube needs, and we've got a connection now, so it should be pretty good. There's just a few little things I have to learn about the new software to make it work right. We did have to buy one additional piece of hardware, the Kryptonite Paraphase Thunderbolt Greaser Slapper. I got that in just a few days ago. We got it hooked up and it seems to be working pretty good. All the lights look good on it there. Okay, so we're on international shortwave on 6130 now. We moved over from 5130 to 6160. I'm sorry. So if you're out there listening, you're listening to an amateur radio or a ham radio program on 6160, and we'd love to hear from you. I've listened to the station before, and it seems to get out very well now, much better than the other transmitter did. Send us an email to tom@w5kub.com. That's tom at whiskey 5 kilo uniform bravo.com, and give us an email. Let us know if you heard the show, how you found us, where you are. Give us a signal report. We'd love to hear from you. Also, if you have internet access where you are tonight, you can actually tune in and watch the show. Just go to w5kub.com and you'll be able to click on live chat and video. You can watch the show and you can also chat with us. Now, here's one little secret. The show you're listening to right now is last week's show. So we're doing a time warp here. The shortwave broadcast is always going to be 1 week behind our live show. And the reason we did that is because when we went over to the new transmitter, we couldn't get the full live time slot we needed. So we're actually coming live at 10 p.m. Eastern Time and going till midnight Eastern Time. So we didn't have any way to really get that audio to them for today's show. So we're just 1 week behind. Just wanted to explain that to you. But it's still a good show. And if you do go to w5kub.com and get in a chat room, you can actually chat with us right now. I mean, we will be live. We won't be recorded. And you can actually watch the show, too. You know, you can watch the live show. So that's what's going on in shortwave right now. We'd love to hear from you. Also, the 40 meter net tonight, boy, the bands are getting great. 40 meters it's just, signals are starting to sound good. I was talking to 20 watt stations tonight that were running 25 over S9, 20 watts, 40 watts, 80. I mean, people sound like they're running amplifiers. We had about, 30 people or so joined us tonight, and feel free to join our, our 40 meter net anytime you can. Tuesday nights is at 5:30 Central Time. All right, so I think that's all the announcements I've got right now. Let's just go around the room here and see who is here tonight. So first one pops up is Alan. Hey, Alan, how you doing?
Hey, good evening. Good evening, everybody. Glad to make it in here tonight. No more technical difficulties, and I got a chance to refine my little chat about oscilloscopes later on today, so it was some fun with that.
Okay, and while we're doing this, I want to take my picture off of this. Let's see.
I know you just want to sit on top of my scope.
Yeah, I guess I need that one right there. There we go. Okay. I've got so many camera shots lined up here, it's hard to see the little postage stamp. Okay.
Alrighty.
My audio needs to come way up, you're still telling me. Oh, Alan's audio needs to come up. Okay,
All
Alan.
right, let me move my microphone closer here, and
Yeah.
I'll see if I can, in the meantime, check my settings.
Okay, well, that's great. And, with everybody on their own Zoom out there, different people are going to be talking into different mics at different distances. So we'll get this right. If I mention to you, speak up or speak down, just follow instructions tonight. Okay, well, great, Alan. Good to see you tonight. And I see the 73 shirt. You're not saying goodbye, are you? I mean, you're here for the whole show.
No, I'm here.
Okay, you're here for
I
the
just
show.
got to check my mic level here, and let me know if that's better there.
It could probably go up a little bit.
All right, let me get up a little.
Go ahead and turn it
bit
up a
more.
little.
There we go. So I don't want to go too high. I think I went too high last time, and they said it was way too loud. So this should be better.
All right. It still looks low on the
Okay.
VU meter here, but that's okay. You're about half what I am.
Okay.
So I'll just
bump it up a
talk.
little
I'll
more.
just talk lower. How's that? All right. Let's see who's next. Let's see how Katie sounds tonight. Katie, how you doing, Katie? Where's Katie?
I'm here.
There she is. There's
Here we are.
Katie and
Hi.
Dwayne. There you are. All right. How you doing, Katie?
You're good.
We were
Good
worried.
tour again tonight.
We were worried about you, Katie. We were all worried, and you were 1 minute late tonight.
I know. Well, my computer was taking forever to get up and running. I thought,
Yeah.
oh my God, I hope I didn't have a Windows update when I wasn't
Well-
paying attention.
And I've used that excuse before too. All right, so I know you changed jobs. I know you had to work one night. Are you still trying to do yoga?
I am. I just came from yoga, which is why I'm still dressed like this. And
You still
it was
dressed for yoga, huh? Okay.
Yeah.
Can you do some
Sorry,
yoga?
but Bill
Can you
said
do
my audio is low.
Can you do some yoga moves for us?
I'm sorry. What was that?
I said, can you do some yoga moves for us?
No.
I didn't think so. I didn't think so. Okay. All right. Very good. Okay. Let's see. Katie is low too, huh? Katie's audio is
Well,
low
because
too.
my micro. Are we gonna bump it up here?
Okay. Now you're okay. Yeah, this is going to be difficult. We're all going to have to learn how to get our levels kind of on the same. I can do only so much here with everybody coming in different. All right. Well, very good.
On the mixer here too. If you tell me
Very
how to
good.
do it.
Let's pick up. Hey, Glenn, how you doing, Glenn?
Hey, we're hanging in there.
All
Like I
right.
said, we had a rare appearance from Godzilla earlier tonight.
Yeah.
So they're destroying the work table, stealing parts and everything now.
Well, do you know where they put them?
Most of the time.
Yeah. Okay. Well, that's good.
I figure, the dog next door is barking and they've stolen a laser pointer pin, so I think there's going to be a 300-yard neutering in the offing here soon.
Yeah. Yeah.
But, no, we're just working on the next Arduino book and hanging around, enjoying the quote-unquote vacation that I'm on for right now.
Okay. Well, great, man. Get that book finished. Looking forward to it.
I'm working on it as hard as I can.
All right. Let's see. Bill Brown. You there, Bill?
Yeah.
Where's Bill? There he
Everybody
is.
tonight?
We got to get Bill some lights. We got to get him. We got to get him some kind of drop cloth banner, behind and some lights.
I got one.
Okay.
It's used for now. I've really gone a little too far on that.
All right. Well, you got plenty of light on your face. That's pretty good. All
yeah,
right.
it's one of those ring LED things that
Oh,
they
okay.
use for TikTok video and YouTube. They sell to the kids, and I said that's perfect, so I bought one. So
Okay.
it was worth it. It's cheaper than what I could find just for that ring light. It's just a ring of LEDs with a little globe on it, and you can adjust the settings. So it works pretty well for this kind of stuff. I'm going to get another one so I can really increase the lighting.
Okay. Well, we're gonna have to work on your studio. We'll work on it there. You shouldn't have spent $5,000 on a camera. I mean, there's other things you could have put into your studio there, but
There
Okay.
you go.
all right.
Well, I can't do backgrounds on my computer. My computer's too slow, so I can't do Zoom backgrounds. So I have to go the old-fashioned way with a green screen. This comes
Yeah.
with a green screen, so I should try that.
Yeah, okay. All right, let's see. Who am I missing here? Let's see. We got to get Rich in here. Hey, Rich.
Hey there. How's everybody doing tonight?
Doing good,
Glad
man.
to be here. I
Hey.
don't think my lighting is much better than Bill's, but
No, yours is pretty good there. Hey, I see an oscilloscope back behind you, and we're going to be talking about
Yeah.
oscilloscopes tonight.
it
Yeah,
is a fairly ancient one. It's a Dumont.
a
it still
Dumont.
works.
Yep, yep,
I had one of those.
I still do.
a Dumont. I got one that looks similar to it up in the attic, but it's not a Dumont. Did Ico or somebody make one that looks kind of like that?
I think so.
Some of the Icos look like that, and even some of the early Heath kits look like that.
I was
Yeah.
gonna say the early Heath kit.
Yeah, yeah, okay. All right, now, who did I miss? Did we get everybody?
I think you did.
I think, you
I
got
think we got everybody. Okay. Okay, so we're going to get started here in just one second. I want to show everybody. I was seeing people in the chat room talking about microphones, get rid of the PR40 microphone. So I've got a PR40 mic right here. You know, and I want to tell you. So right now I'm on my lapel mic, and if I turn my head this way or walk across the room, my audio is about the same. Now I'm going to turn my lapel mic off. Watch this. All right, now I'm on the Heil PR40 mic. Now watch this. If I turn my head like this, testing 1, 2, 3, 4, 5, you don't hear me. Testing 1, 2, 3, 4, 5. Testing 1, 2, 3, 4, 5. Or if I happen to look over here at the audio board, you're probably not hearing me. So, man, you got to talk right into these microphones. So let me get my lapel back on. All right, the lapel's back
Well,
on.
it's designed to be a very directional microphone.
It is, and it is, and it's a good microphone, I'm sure, but for our amateur webcast here, I found that the lapel mic does better. Okay, well, so let's do this. Katie, let's bring you in here and Rich in here, because you know all the questions to ask. Go ahead, Katie. Let's get Rich in here.
right.
Let's talk CQ. We're going to talk CQ magazine, and looky here. There's CQ magazine right there. All right, go ahead, Katie.
All right. Well, how's my audio now? We're kind of playing around.
Yeah,
with the,
it's like
You've got some
18.
buzz
It's
on
like 18,000 dB.
And you got a
all
lot
right,
of
how
hum.
about 17,000 dB?
N-
16,000 dB?
Now you're about a minus 50.
All right. How about if I just pull my mic closer?
Yeah, let's see here.
We'll just hide Dwayne for a minute.
All right. We'll figure this out. Yeah, pull the mic a little closer.
All right.
All right.
Sorry, honey.
Give me a mic test, Katie.
All right. How about now? Test, mic test. There,
I
Dwayne
think
can
it's
hide
okay.
underneath it.
It's
Is that
fair.
better?
Well,
Yeah, this is how I
Yeah.
usually do it, but since I have
I'll
my
tell you
partner
what.
in crime over here.
I'll turn you down. I'll turn you down if you get too loud.
Okay. All these
Do you remember,
technical
Katie, what we're supposed to be doing right now?
Yes, we're supposed to be talking to our friend Rich W2VU from CQ Magazine. So bring him on, will you? Where is he? There he
I guess with
comes.
Zoom, I need to start talking before.
Oh, there we
Yeah.
go. Yeah. Hi, Rich. How are you doing? Nice to
I'm
see you
doing
again.
fine. Good to be here. And
Good.
glad the show is able to stream tonight.
Yeah, absolutely. I'm glad too because since I missed you last time. So good to be able to catch up with you and find out all the cool things that are happening. I know that one thing in particular was kind of exciting is that Tom had an article in the recent CQ. But that's this month. Is that this month or this?
It's this one. Yep.
Yeah, it's this month's episode.
Yep.
Episode of CQ Magazine. So tell us what's coming up in our next issue of CQ.
Okay, well, the October issue, which Tom already showed you the cover of, so it's our emergency communication special. And the cover and the first story actually are not about emergency communications. It's about what the author thinks is possibly the world's best contest QTH, EF8R in the Canary Islands. And it's quite an interesting article with lots of great pictures of great antennas and station and stuff like that. And they had survived a hurricane and a few other things. So it's a really cool article, very interesting story. Then we move into our emergency communications segment. We've got W9JU with an article on planning your first amateur radio exercise or event. You know, so much of what you see in the ham media and get on the air in terms of training relates to being one of the operators at an emergency event or a public service event, and how to operate properly on a net and things like that. There's very little attention paid to the people who have to put it together and organize it. And that's what Scott has written about here, for the benefit of the person who has just been asked to put an event together. Where do you start? What do you do? How do you make it work? And so it's a really good educational piece and good reading too. Bob Berninga, WB4APR, the inventor of APRS, has a second passion, which is electric vehicles. And he's bringing that together with ham radio with an article on backup power for when your grid goes down, where he's basically using your battery from your electric vehicle to power your station and maybe a little bit more. It's a good source of energy and rechargeable by driving. So
That's pretty cool.
yeah. WA9PYH has an article on WinLink, which is email by radio for those who are not familiar with it, which can keep you connected when all else fails, as the saying goes. A lot of digital stuff today is formatted as email, and having the availability of a radio email system can be very useful, particularly when standard email isn't available. Sherlock, our resident electronics detective, investigates a failure of a USB connector that just shot down his whole operation. It was a remote operation, and he had failed to check the cable before he left and didn't have a backup, and one bad cable messed up his whole operation. So that's something to keep in mind there, and he writes
That's
about
devastating. Look forward to reading that one. Yikes.
So beyond MCOM, we've got this guy named W5KUB, who's written a great article on adventures with pico balloons using amateur radio. And mostly the story of, I think it was number 18 that made 3 trips around the world, plus some more, and what went into putting all that together. So great article by Tom there. Mike Traffy, N1HXA, who invented the hex beam, has an article on the hex beam revisited. And he's continuing to study and discover new things about the antenna design. So he shares some of them with us here. K5KG and W4LT have an article on, this is appropriate for here tonight, How's My Audio is what it's called. So it's all about adjusting your transmit audio on single sideband to be the best that it can be. So I think we all need to take a closer read to that one tonight. And finally, among our features, we have K8HSY with an article titled The Day I Let the Smoke Out. Because as we all know, electronic components are filled with smoke. And you don't want to let the smoke out. So
We all know that smell.
that's right.
I don't think anybody doesn't know that smell in this hobby.
Hey, if you abuse them too hard, you let out the fire.
That's
Yeah.
right.
Yeah.
And then you're left with some leads pointing to where the part used to be.
That's right.
Oh, man.
So getting to our columns, we have our kit building column, of course, with Joe Eisenberg. And his title this month is May the Morse Be With You. Go along with Glenn's t-shirt there when he gets on, about going to the dark side. Then Scott Rout, our QRP editor, K8SMA, has an article this month on QRP and POTA, Parks on the Air, a perfect match for fun. Jeff Reinhardt, AA6JR, our Magic in the Sky editor and mobiling editor, depending on which hat he's wearing, has a commentary this month wondering if it's time to rethink how we do our license exams in light of all of the difficulties that we've had and the innovations that we've had as well over the past year in doing traditional license exams. He's wondering if it's time to just take a new look at how we do them on a regular basis. Our learning curve editor, Ron Oshu, KO0Z, has a piece on antenna tuner basics. Very useful article. Many of us who don't have the luxury of single band antennas have to rely on an antenna tuner, and this is a good guide for getting started. And speaking of antennas, antenna columnist Kent Britton, WA5VJB, has an article titled Measuring Things You Can't See. So you have to wait until you see the article to know what he's talking about. But I'll give you a hint. It's radio waves. And our VHF Plus editor, K8ZR, shows us how to work meteor scatter with MSK144. That's the latest WSJT incarnation of meteor scatter digital mode. Contesting editor Tim Schappa, N3QE, who's new contesting editor, has some analysis of the continued spike in contest operation due to COVID-19. It's been a positive result of a very negative situation. A lot of more hams are at home and on the air, and contests are benefiting greatly from having much more activity. So he's got some analysis there, not only of just the straight numbers, but also breaks down by license class of the operators who are entering and submitting logs. And finally, propagation editor NW7US offers a prediction of good conditions for the CQ Worldwide DX SSB weekend coming up at the end of this month. As you hopefully know by now, we have begun Cycle 25, thankfully. Good riddance to Cycle 24. And we'll see stuff starting to climb, hopefully, pretty soon. And even more, hopefully, pretty far. So we'll see how that all works out. That's the basics of the highlights of the October issue of CQ. There's more, of course, but I don't have time to do everything.
Is that it?
Besides, if I did it all, then you wouldn't have to read the magazine. So.
Well, that's great. Do you have any special? We should let people know if they aren't currently subscribed right now. You can get online and order up your subscription at www.cq-amateur-radio.com. And we have a subscription special going on that I think is ending the end of this week. So this would be a good time to get in there. Basically, it's one additional issue for each year that you order. So it's 13, 26, or 39 issues instead of 12, 24, or 36. So it's a really good deal. And it's about to expire. Oh, and our calendars are in. If you'll talk for 1 minute, I will go get one and show it to you. So okay.
Put you on camera.
What are we gonna do for a minute to talk? Let's see. So anybody in the room here going to be doing CQWW later this month?
I wish I was.
Yeah. Well, why aren't you?
I'm writing a book and I'm late.
Oh, all right. I guess that's a good excuse.
I'm trying.
He's about 2 years late on his book and he still hasn't come up with it. George R.R. Martin is 5 years late
Yeah.
on his book.
Actually, I'm only 4 years since the last book, but I've had heart surgery in between that too.
Yeah, excuses. All right,
Yeah,
Rich
I
is
know
back
it.
with Rich is back with a calendar. What do we got,
indeed.
Rich?
Here we go. So hopefully the lighting is not bad on it. This is our cover. That's Kylie Sherbrun, with whose dad Randy is a big soda person for Summits on the Air, and when Kylie comes along, she likes to work the satellites from the mountaintops, and that's what she's got here. And we've got, let's see, January we go to Holland with the Ham family there and friends.
Nice.
We've got
There's Jerry and Val.
Jerry and Val, yep. And they're same picture that we had on the cover of September, actually.
Oh, yeah.
And here's how to do social DXing
There you
safely.
go.
They need to put that microphone inside the mask. Yeah. Hey, that gives me an idea. Why don't we start up and sell masks with built-in microphones?
Hey, that's a cool idea.
Yeah.
I'm sure somebody will come up with it.
You've
Yeah,
already given up your idea now, Tom. It's out in the
Yeah.
open. And
yeah.
you have no jump on it.
We're gonna have to
It
get
was
Dwayne.
W5KUB's idea first.
Yeah,
That's
and
okay. I can't sew, so you're all are safe.
I'm just gonna glue it in. Yeah.
Let's see. This is a nice fox hunting picture with our Newsline Young Ham of the Year in the hoodie there. It's Chris Brault, KD8YVJ. And here's Randy, Kylie's dad, doing a soda operation from a mountaintop in Colorado. And here's Kylie again on July. Same pictures on the cover. And let's see. August, we go grid DXing. This is an operation from a grid corner of, let's see, DN56 and DN66 for handing out grids for people who are looking for VUCC and stuff like that. Nice contesting station in Japan, JH4 UYB. He's got no room for any more plaques on his wall, so I don't know what we're going to do, what he's going to do the next time he wins a contest. Here's another mountaintop operation. I don't know if I see that too well with the lights. That's Eric Holmberg, KC1FGY, up on Mount Cardigan in New Hampshire. Not wearing a cardigan. Great picture of a cool dish antenna for EME. And speaking of dishes, this is a photo of the first, or not first, but record-setting 122 gigahertz QSO of it was made last February over 86 miles, which is pretty impressive for 122 gigahertz. We need to get more people on more microwave bands. Of course, the calendar wouldn't be complete without a workshop photo. This is KH6WZ, our ham notebook editor, and you'll notice his ham notebook right there as he's working on a project. And nice set of VHF, UHF Yagis. This is from Alaska, KL4E, Craig. And he put those up while he was in quarantine for 2 weeks after coming back from a conference. And finally, we wrap up with a nice springtime shot from, where are we here? It's V26 VB and British Virgin Islands. This was the operation commemorating anniversary of Danny Wiles' operations with his call sign V26VB, and you got Marty Lane, OH2BH, Adrian, and a couple of other people So that's takes us through March of 2022. So
All right.
calendars are available, and ready to be shipped.
I thought for sure that you would have a picture of Dwayne on the December month.
Well, we're just starting the December issue, so we do have room on the cover.
All right, very good.
He's got the right color shirt on there.
That's
I
right.
got the red and white suit.
Yeah, he does. Hey, you've almost got it right now. You almost have the look right now. There you go. Can I get?
I think you need to gain
Yeah.
20 or 30 pounds, though, Dwayne.
Can I get a ho ho ho?
You know, I used to be about 20 or 30 pounds heavier than I am now, and I'm glad I lost that.
Yeah.
All
I
right,
gained it.
we're gonna have to get Dwayne a microphone too. Okay.
Thank you, Rich.
My pleasure, and we'll see you all next month, if the time warp remains
Yeah.
in flux here.
All right.
Actually, we'll see you again later this month because we're in the middle of October already. So
That's right.
2 weeks, I guess, 2 or 3 weeks. I gotta look at this year's calendar. Yeah, I guess 2 weeks from now we'll do
Yeah, in
the
2
November
weeks.
issue.
And let me also say in 3 weeks I normally don't do this, but in 3 weeks we probably will not have a show because that falls on Tuesday night and that's election night.
Right.
That's probably not a great night for us to try to have a show, so we'll skip the election night show, and we can all get popcorn and have fun somewhere else. So anyway, but we'll be back after that. So Rich, we'll see you in 2 weeks to talk about next month.
Great.
All right, man. Thank you so much.
My pleasure.
All right, guys, we'll be right back in just 1 second here. Let's talk about a brand new ICOM radio. Get out and be active with ICOM's new IC705. The IC705 is your perfect QRP companion as you have base station features and functionality at the tip of your fingers in a portable package. It covers HF through 70 centimeters. This compact rig weighs in at just over 2 pounds with RF direct sampling for most of the HF bands and IF sampling for frequencies above 25 megahertz. It also has a large 4.3-inch color touchscreen with live band scope and waterfall. You get 5 watts with the BP272 and 10 watts with a 13.8 volt DC power supply. It has a micro USB connector, Bluetooth, and WLAN. Integrated GPS with antenna and a GPS logger. It has a micro SD card slot, and the HM243 speaker microphone comes standard. The perfect accessory for the IC705 is the LC192 backpack. It has a special compartment for your IC705 and room for all your accessories. The IC705 now has received FCC certification, and we expect product to be shipping to dealers by the end of September. Visit www.icomamerica.com/amateur for more information on ICOM radios.
LDG Electronics provides state-of-the-art antenna tuners for every amateur need. From QRP to QRO, fixed stations, portable and remote, an LDG tuner will match your radio to your antenna using our lightning-fast, proprietary tuning algorithms. LDG is a family-owned and operated company dedicated to bringing innovative, quality products to the amateur market. All LDG products carry a full 2-year warranty that is fully transferable. Support is only a phone call or email away. We're always here to help you. Visit us on the web at ldgelectronics.com.
All right, and we're back. Okay. All right, we're a little over 30 minutes in the show. Just let me mention again, in case you just tuned in on shortwave, you're listening to Amateur Radio Roundtable, a show about ham radio. And we're new on 6160 kilohertz. Send us an email if you're listening to the show. Love to hear from you. Send it to tom@w5kub.com, tom@w5kub.com. And if you got internet with you right now, you can join the show live. The show is the URL is w5kub.com. Just click on live video and chat. You can join the show, watch it, and be in a chat room with us. All right, we're going to talk a little about, we're going to talk TekTips next. Let me see if I can bring Alan in here. I think he's got something real neat. I was looking at one of the, Alan, I was looking at one of the Facebook groups the last couple of days, and they were
Yep.
talking about getting an oscilloscope and asked if it could be used for anything, and you already saw all the different answers. And yeah, it's great if you need it, but if you don't need it, you don't need it. And, we used to use it
It's
on
one of those
this and
tools
that.
that once
So
you have
anyway,
it, you find things to use it for.
let's talk about it, and you can give us a little, I don't know, a little lesson on it.
All right, we can do that. So anyway, good evening and welcome to TekTips. And let me do a quick little share here. And this is actually a presentation I've given to several amateur radio clubs over the years. I'm going to go through it a little bit quick tonight, just because I usually kind of stretch it out along with some demos and things like that. But we'll just kind of go through it as a kind of a high level this evening here. So just the basics of oscilloscopes, how to use them. I even have a couple of slides on different ways to use them in the shack. But if we get to that, we'll get to that. So let's see. So just a quick little agenda. We'll talk about the basics of analog scopes and digital scopes and a little bit about probes and maybe a little bit more after that. So the old school analog scope, a couple of pictures on here, but really all it is you can think about the CRT as kind of like a television screen. There's an electron beam that's fired towards that screen that lights up a little trace as it sweeps by, and there's deflection plates that move that beam left and right or up or down. And you can think of an oscilloscope as a graphical voltmeter to kind of show you changes in voltage over time. And then all the controls are just to help you get the things that you want to see up on the screen. So there's basically a sweep control that controls how fast the beam is going to move across that screen. And then whatever signal you apply determines how much the beam gets deflected up or down. And the rest of it is just all controls to set all that up. So some of the controls that just control the display itself are generally just the intensity and focus controls, and I've shown just a couple of little pictures of what they might look like on different scopes. And those are the main things that you might have: intensity and focus. Some scopes will have a trace rotation feature, and that's depending, because the trace can kind of get tilted sometimes depending on the magnetic field on your bench. So the trace rotation will kind of flatten that out for you. And then there's a couple of other things like a beam finder that helps you find the trace when it's way off screen and stuff like that. But those are the basic controls just for controlling the brightness and intensity and focus, if you will, of the trace on the screen. The thing that we'll be adjusting probably more often than anything else on the scope is the vertical system. The vertical system is going to determine how much the voltage that you apply at the input is going to move the beam up or down on the screen. And there's a bunch of elements that are part of that, but really at the end of the day, you're just adjusting essentially the vertical sensitivity, the volts per division, and maybe a position and a coupling, AC or DC coupling of the signal, so to control how the beam gets moved up or down on the screen. One thing I'll mention about oscilloscope inputs is they are not the same thing as using a pair of probes on a multimeter, right? You're always, when you measure voltage, you're always measuring voltage between 2 points in a circuit. With a DMM, a multimeter, a VOM, those 2 points can be anywhere. You can touch the probes anywhere you want in different points to look at the voltage. With an oscilloscope, that's not the case. In the oscilloscope, one side of the probe, if you will, the ground clip, is always at ground, unless you've got an isolated scope, which is a rarity. Most scopes are not isolated, so the ground clip is at ground. If you're working on battery-powered circuits, it doesn't really matter. But if you're working on circuits that are actually tied to, a main power supply somewhere, or plugged into the wall or something like that, you really have to take care of where you put that ground clip, because it's always at ground. So if you place it on a part of the circuit that is not ground, you short that thing to ground. So be careful where you place that ground clip. Okay, so that's the only, so one thing to keep in mind, it's that it's not just like probing around with a multimeter. When you go to measure a signal, you can determine how that signal that gets coupled into the input is brought to the vertical deflection plates. DC coupling means that if you have a DC offset on the signal itself, you're probing a DC signal, you're going to see the DC offset and the signal itself. AC coupling allows you to remove that DC offset, and that could be handy for looking at things like ripple on a power supply, right? Let's say you've got a 12 or 13.8 volt supply. If I wanted to view that, if I DC couple, I might have to set it to 2 or 4 or 5 volts of division. So if I'm looking for a ripple of 100 millivolts peak to peak or 50 millivolts peak to peak on that 13 volt supply, you would barely be able to see it. But if you AC couple, you can remove that DC and set the sensitivity of the scope down to 100 millivolts of division or 20 millivolts of division or something like that, and get a better view of that small level of AC riding on top of the DC. So that's why you want to think about AC or DC coupling. You set the vertical scale by a volts per division control, and this is on most scopes these days. Some of the older scopes were not calibrated, and you might see something like these controls all the way on the left, where you have a vertical gain and a vertical input attenuator. Everything is relative on those scopes, whereas scopes that actually tell you a given number of volts per division you get a calibrated volts per division. But it also means that the little vernier knob that's in the middle of them, you want that generally turned all the way to the right, generally to where it clicks when you're in the calibrated position. If you rotate that to counterclockwise, you can go to an uncalibrated vertical scale setting. But that's the typical vertical controls. Signals are typically coupled in through a BNC connector, either directly or with a probe. And we'll talk about probes in a minute. Vertical modes, if you've got it more than a one channel scope, you can tell it I want to look at channel 1 or channel 2, or maybe I want to alternate back and forth between them or chop between them. The alternate and chop are ways of looking at more than one channel at a time. Most of the scopes, the vast majority, only have one trace. But if you put multiple channels on, it can either alternate between channel 1 and channel 2 with each sweep. And if the sweep is going fast enough, you don't notice it. It just looks like two traces on the screen. If you're going at relatively slow sweep speeds, okay, where the beam is moving across almost where you can see it, then that alt mode, you're going to see you bounce back and forth between the two channels or the multiple channels. That's where the chop mode is used. When it chops back and forth between those two channels very quickly, and you don't see that. So that's the other vertical modes. Now I mentioned that you can't really probe across a component like you can with a multimeter, like if you want to measure the voltage across a sense resistor or something like that. The add and invert controls on the vertical mode allow you to do that, because you can say probe on one side of the component with channel 1, the other side on channel 2, and if you invert channel 2 and add them together, it's the same thing as taking the difference voltage across that component. So that's the way you can measure a voltage across a component like you can with a multimeter. Okay, so that's all the vertical controls. The horizontal controls basically determine how fast the beam is going to move across the screen. It's like how fast you move your pen across the paper if you're drawing out a waveform. Okay, and the typical controls are to set up how many seconds or microseconds or nanoseconds or milliseconds it takes for the beam to go per division across the screen. Then there's some tie-in with the trigger we're going to talk about here in a minute. Okay, but it's typically called a sweep time control. And on digital scopes, it's called a horizontal scale. So now on some of the old school scopes, some of the real old scopes that are called recurrent sweep scopes, you don't have generally a calibrated sweep rate. You'll typically see something like a horizontal frequency selector and a vernier control. Again, not calibrated, but allows you to kind of adjust how fast you're ramping the horizontal voltage, which basically is how fast we're going to slide or pull the beam across the screen. Generally, again, in most scopes that you can find these days, even used scopes, are going to be triggered sweep scopes, and there's really almost no excuse to be using an old recurrent sweep scope anymore. So I would say always try to go and find the triggered sweep scopes. The triggered sweep scopes will send the beam across the screen in response to a trigger, so that you always can get a nice synchronized response to the waveform that you're looking at. That's a lot harder to do with the old recurrent sweep scopes. So always look for something that's got a triggered sweep scope, and the way you can tell that is you have a calibrated sweep time per division control with a certain amount of time per division, as opposed to a vernier frequency control on the horizontal. So why do we want to trigger on a signal? Generally to stabilize the waveform on the screen, because again, we're looking at an AC waveform, whether it's a voice waveform or we're looking at a, our RF signal or something like that, or whatever we're looking at. We want that waveform to be kind of continuous, or stable, like you've drawn it on a piece of paper. So that means you got to match the sweep speed to it on the old recurrent sweep scopes, and that's kind of tough to do. What the trigger does is the trigger allows you to pick a point on the waveform to say, I want to kick off the sweep when my voltage crosses that point, or I satisfy that trigger. So every time the signal crosses through that point, you'll kick off another sweep. So all the waveforms land on top of each other and you get this nice stable display. Okay. So trigger level and slope, this is a very simple edge trigger where you basically set a threshold with the level control, and you set a slope, meaning if in this case the threshold is down a little bit above ground, say up here, the slope saying when I cross through that threshold going up from below it to above it, that's a positive slope. I want to trigger then. If I flip the slope to the other way, I'll trigger when I come down through that threshold. So it's a pretty simple thing. In fact, what I'll do here real quick is let me share a scope screen with you all. Okay, just to kind of show you what it looks like. This happens to be a digital scope, but you'll kind of get the idea here. So you can see this is my trigger level here. If I adjust, and you see the trigger point is right here in the middle. So I'm triggering right when I'm crossing through that level in the middle. If I bring that trigger level up, you can see that now the waveform is moved, and I'm triggering when I cross that level up here. Similarly, if I bring that level down here, we can see now that I'm triggering when I'm crossing that level. And that's triggering on the rising edge, or the positive slope. If I change that to the falling edge, then it's going the other way. Okay, so that's kind of what I was talking about with those trigger controls. So let's go back to my presentation here. So there's a lot of controls for the trigger, so you can precisely look at the signal you want to look at. Generally, you're going to be triggering on the internal source, meaning I'm picking off a signal from what I'm applying, and I'm going to use that to control how I trigger. You also have the option of triggering on the line. That means triggering on the power line that your scope is plugged into. And that can be very handy if you're looking for things like ripple in a power supply, because the ripple is going to be synchronous with the line frequency. Unless you're in a switching power supply, then it's different. The trigger mode. We'll talk a little bit about this and talk about what auto trigger mode is and what it isn't on the next slide here, and then the coupling for the trigger and how it goes in. But generally, internal triggering, auto mode, AC coupling is all generally the thing that will get you to trigger almost all the time and get you a nice stable display. So let's talk about what auto trigger is. People might think that auto trigger automatically sets up your trigger settings for you. That's not what auto trigger is. Okay. Auto trigger is basically a usability aid, because if you set up in what's called normal trigger, which is the second button here on this little picture of this 465 scope, what normal trigger does is that if I've got this trigger set up and my input waveform is not satisfying whatever trigger condition I've set up, the screen is blank. It doesn't give you any information about what's going on. Okay, so what auto trigger does is it sets the scope to wait for the trigger that you defined. If that trigger event doesn't happen in, say, 50 or 100 milliseconds, it self triggers and just sends a trace across the screen anyway. Okay, and what that does is it makes sure you're not just staring at a blank screen, and you can see, oh, my signal is up here, or my signal's down here. I can see what's going on with it, so then you can properly adjust the trigger levels to trigger on that signal where it is. So it puts a trace on the scope screen, even if it's not triggered, to at least give you an idea of what's happening, so that you can properly set things up to trigger on it. So if you're looking at your scope and the trace is not synchronized, it looks like it's sliding back and forth, or what we call rolling, then it might indicate that you're in auto trigger, but your trigger is not set up properly. Okay, so that's what auto trigger is. It's not an automatically set up your scope type of a thing. So let's talk a little bit about the difference between analog and digital scopes. And we focused so far primarily on analog scopes, where the voltage that's applied to the scope determines how much we vertically deflect the beam that's going to the screen, and then the time-based settings, or sweep settings, control how fast we move the beam back and forth. The digital scope works very differently. It's basically just takes pictures. Okay, so inside of a digital scope, the input signal comes in, gets conditioned, maybe attenuated or amplified, and then it gets digitized with an analog to digital converter. And then those samples, basically taking pictures, almost like a movie camera takes still pictures, and then when you play the movie back, you're just playing back the still pictures fast enough that it looks like a moving picture. This is the same type of thing. It's just taking snapshots of the voltage at instants in time, and basically taking that waveform of sample, that set of samples, okay, and processing that data, putting it into memory, and then figuring out how I'm going to take those values and draw a waveform based on those values. So the front end is basically the same as the analog scope, but once you get past that, everything else is pretty different, okay? And trigger in this case, instead of the trigger acting to kick off the sweep like it does in an analog scope, the trigger is more of a qualifier to saying when the trigger is satisfied, that's the bit of samples that I want to save and display. Okay, the scope is generally sampling all the time, and then when the trigger is satisfied, it looks and says, oh, okay, you triggered based on this aspect of the waveform. Those are the samples I'll save and put on screen for you. Okay, so it does work a little bit differently in the back end compared to what the analog scopes do. And you've got to start thinking about things like sample rate and memory. Sample rate is how fast we can take those snapshots. Okay, ideally you want to take those snapshots very, very rapidly, because as you reduce the time between those snapshots, you get closer and closer to the actual approximation of what the waveform looks like. The downside is that if you sample really, really fast, you burn through memory really quick. You have to be able to store all those samples that you save. Okay, so there is this equation that says that if I sample really, my sample rate times the acquisition length tells me how much waveform memory I have to have. And if you don't have enough waveform memory to look at something, then you got to reduce the sample rate to fit the waveform you want to see. So oftentimes the waveform memory is a lot deeper than the number of samples that are displayed on the screen. Okay, I might be able to save, 10,000 points or 100,000 points or 1,000,000 points or much more than that on the scope. But the display on a digital scope is just an LCD display. It's got a limited number of pixels it has, so you can't possibly display every sample point. So generally what will happen, there's going to be some sample processing that's going to take the samples that are sitting in memory and doing something with them to create the samples that are displayed on the waveform. And oftentimes with digital scopes, you'll have this display interval, and then all of the samples that would, kind of go from one interval to the next are kind of thrown on top of each other to create this kind of cloud, to create this kind of intensity graded waveform to simulate what you'd have on a CRT. But so you've got to be careful about how waveforms are generated, sampled, and then processed on the display sometimes, especially if you're trying to push the limits of what the scope can do. Okay, most of the scopes try to take care of this all in the background for you until bad things happen, and we'll talk a little bit about that. So the digital scopes have some advantages over the analog scopes. One is you can capture a signal and then zoom in. Like maybe you see a little bit of a glitch on a waveform, zoom in on it and see what's going on. You can do single shot captures. So I can capture a waveform, stop, and go look at it. All right, on an old analog scope, the waveform is just drawn on the screen, and if you don't see it when it happened, it's gone. What we used to do in the old days is put a Polaroid camera on the front to take a picture of a single shot event and then develop that Polaroid picture and look at it. And then there were also some specialty CRTs that actually would do storage on the phosphor of the CRT itself, but they were, you'll still see some of them out there, but they weren't nearly as popular as just the regular analog scope. So the single shot capture thing is a natural thing with the digital scopes. It just didn't happen very easily with the old, natural with the digital scopes didn't happen very easily with the analog scopes. The other nice thing about the digital scopes is you can look at pre-trigger information. As you saw in the scope when I brought it up before, the trigger was in the middle of the screen. So I was seeing what was going on leading up to the trigger and then what was going on after the trigger. So this can give you a lot of flexibility in terms of understanding what's going on with your circuit, because maybe the thing that you can trigger on only happens at the end of the interesting event. So you can actually look at things that were going on before the trigger occurred. And you also can typically have a lot of different trigger types, even some complex triggers to trigger on like an RS-232 bus value or something like that. And of course, to make automatic measurements. Instead of counting divisions, like, okay, how, what's the frequency of this signal? Let's say I've got to count, let's say I've got 1 microsecond of division. I'm going 5 divisions, 1 over 5 microseconds is whatever frequency. You don't have to do that with the digital scopes. You can automatically get measurements of voltage and, peak to peak voltage, average voltage, frequency, period, rise time, fall time, things like that, because the samples are all in memory. And it's just a matter of doing some math inside the scope to give you these automatic measurements. So all these things are things that come along with the digital scopes that you don't get with the analog. Okay. You also can do waveform math. This screenshot here on the upper right is one where I was doing a video on reverse recovery time of diodes. And this was showing the voltage across the diode, the voltage across the resistor in series with the diode, and then actually doing a division of one over the other to actually give me the diode current. Actually, this is actually the base current. I was actually looking at switching time in a transistor, I guess. But so you can actually do math to compute various functions on live waveforms, which is pretty cool. And even do FFTs to look at frequency domain content, so kind of spectrum analyzer-like features. So all these things you can get with digital scopes. So you might say, well, why don't I use them all the time? Well, there's some disadvantages to digital scopes as well. They can appear to be noisy because unlike an analog scope where the waveform is just drawn, in a beam, any little minor variations that only occur very infrequently are not going to occur frequently enough to make the trace look very fat. So it looks like a real clean waveform. Digital scopes, they don't discriminate, right? They sample everything. So there's a little bit of noise, you're going to see it. So they look noisier. But it's not, you can live with that one. But one of the bigger disadvantages with scopes is that you can alias the waveform if the sample rate is below what we call Nyquist, meaning that the sample rate is too low for the waveform you want to look at. And a good example that I think about this, if you think about when you used to watch the old Westerns on TV, and you watch the wagon wheels on the wagons being pulled by the horses, sometimes it'll look like the spokes on the wagon wheels are going the opposite direction of the way the wagons were going. And that all happened because the frame rate of the video, or the film camera, was taking snapshots at different spots, and where it happened to get snapshots, it snapshotted those spokes in different locations, and then when you stitch that together, it looked like it was going the wrong way. That's an aliasing thing. And you can kind of see here, let's say the red waveform in this middle plot here is the actual waveform. But if I sample it too slow, like where those little green dots are, you can see what happens if I sample it that slow. If I stitch those dots together, it looks like the signal is a lower frequency. Okay, and that's called aliasing, and that can happen. And it's typically something we'd worry about with our amateur radio use, because you might want to use a scope, for example, to look at your RF envelope. So if you're on a single sideband signal, for example, so you'd use a relatively slow sweep speed or horizontal scale to be able to see the voice envelope. But if the RF signal is at HF frequencies, the sample rate might wind up being low enough that you're going to alias the RF, and it may not look so good. So also the update rate can be slow because there's a lot of processing that goes on. They can be pricey, although there's some inexpensive digital scopes out there now. And there's an interesting mode that we use sometimes in the analog scopes, like called an XY mode, that generally doesn't work really well on the digital scopes. Okay, so there's some disadvantages for the digital scopes. So last thing we'll talk about here quickly is probes. Why do we want to use probes? And generally we use probes to minimize the loading of the circuit that we're testing. Because if we just connected up a piece of coax to a circuit, the coax itself is going to, it's a 50 ohm piece of coax, obviously, generally, but it's going to have, several, tens of picofarads of capacitance. If it's a long cable, it might even have more than that. And by the time you connect it up to the scope, you might be looking at 100 picofarads of capacitance. If you're probing around in an RF circuit or in the IF chain of a receiver or something, that might load the circuit pretty dramatically. So these 10x probes are generally designed to minimize that. Okay, and there's also other types of probes like active probes and current probes and things like that. So 1x probes are a direct connection. They can be highly capacitive loading, but they don't cut the signal amplitude at all. So for low frequency signals, audio signals, and low impedance circuits, you can often use those, but most of the time we're going to be using 10x probes. And they're called 10x probes because they actually attenuate the signal by a factor of 10, meaning that the vertical scale gets multiplied by a factor of 10. So you set it to 100 millivolts a division, plug in a 10x probe, it's now 1 volt per division in terms of what the vertical scale is going to see. Again, the good thing is they reduce the effect of the capacitive loading on the circuit. The bad thing is they need compensation. And here's why. So this is a very simple schematic of what a 10x probe looks like. It's using the fact that the input impedance of the scope is typically 1 megohm. So it sticks a 9 megohm resistor in series with that. So that creates a 10-to-1 voltage divider. Okay, that all works fine, except the fact that the scope also has some input capacitance. Because these impedances are quite large, you don't have to go too high in frequency before the input capacitance starts dominating the input impedance. So all of a sudden this looks like a low pass filter, so it doesn't work so well. So what we do is we actually stick another capacitor in parallel with the probe tip resistor, and then by adjusting that capacitor to be a 10x ratio with the input capacitance, we can now get a good frequency response over the wide frequency range and not have that low pass effect. Okay, and most scopes will have you'll see something called probe adjust or probe compensation, probe calibration, some kind of a signal on the front of the scope for you to actually set up and adjust the probes. In fact, what I'll do is I'm going to show you this really quick to show you the effect of this. Let me go back to the scope here and stand up here, and I'm going to disconnect the signal I was looking at here and stick in a 10x probe that's hooked up to a little square wave there. And you can actually see this is supposed to be an ideal square wave. And that's the whole idea with what this compensation signal is. It's supposed to be an ideal square wave. The probe itself has got a little probe compensation adjustment on it. So if I stick the screwdriver in there, I can actually adjust the compensation capacitor in the probe. Here I can see I'm undercompensated, I'm overcompensated there, and the idea is you want to adjust this to give yourself a nice perfect square wave. And now you've got that probe properly compensated for your scope. And I work professionally in the industry, and you would not believe how many people, when they get their scope, they get the probes come with the little screwdriver, and how many people just throw it away, stick it in a drawer, and forget about it, right? And the reality is what happens is if you don't properly compensate the probe, you're going to wind up making errors as soon as that frequency that you're looking at is greater than like even 10 kilohertz. Okay, the amplitude is going to be wrong if you don't properly compensate your probe. So it's always a good idea to properly compensate your probe. If you change scopes, compensate them again, because every scope has got a different input impedance or different input capacitance. So always properly compensate that probe. Another thing to think about with the probe is the ground lead. Remember I mentioned it is connected to ground, so be aware of that. But also keep in mind that if you're looking at high frequency signals, you want to keep that ground lead as short as possible. Because here I was looking with an analog scope at a relatively fast digital edge, and with a 5-inch ground lead here, it leads to ringing on that waveform. And by switching from this long ground lead to a very short little spring lead with a very, very low inductance, probing that same signal, it cleaned it all up. So you have to think about that ground lead. If you're looking at high frequency signals, that essentially adds inductance and can create a little tank circuit between the probe input capacitance and this ground lead inductance and cause ringing. Okay, so you want to keep that ground lead short, especially when you're looking at digital signals, or because digital signals can have fast edges. Fast edges have a lot of high frequency energy, and that inductance can make a difference. So keep that in mind, and that's why when you get your probes brand new, they come with different ground leads and sometimes these little ground clips to clip right onto the end of the probe to minimize that ground lead length and therefore minimize the inductance. I mentioned earlier XY mode. XY mode is where instead of the scope taking control over the horizontal sweep, you can essentially adjust the horizontal sweep or drive the horizontal from another input. Okay, and so you may see, there's different applications for this. For example, if you look at this picture I've got down here in the middle and the bottom, this is kind of using a sweep generator to maybe adjust a product. Maybe you're testing the frequency, like you're aligning a receiver, for example, aligning the IFs in a receiver. We can sweep the frequency in there, send that to the X input, and then take the ramp output from the function generator and use that on the Y input, and essentially trace out what that filter shape looks like in the IF. Okay, so that's one example of that. There's lots of other applications for using XY mode. It's just kind of an interesting thing. You can develop curve tracers and things like that using XY mode. So it's pretty cool stuff. So let's see, how are we doing on time here? I want to make sure we're good.
Okay.
So the layouts of the scopes, generally we'll try to lay out these controls. They look like a sea of knobs. It's like, and you got to be like an airline pilot to pilot these things. But the reality is they're laid out generally pretty logically. This is showing some analog scope layouts, and you'll see that, if I look down here, all my vertical controls are all kind of grouped together, right? My volts per division control, the coupling, the vertical mode, vertical position. They're all so all this controls the vertical aspect of what's going on in the scope. Here's the horizontal controls, horizontal position, my horizontal sweep time, okay, and seconds per division right there in the middle. And then here's all my trigger controls, okay, how I'm going to set up the trigger. And you'll see that that's pretty common on the scopes. They'll generally have these areas that are laid out for vertical, triggering, horizontal, etc. So, but generally the analog scopes are going to have more knobs and buttons on them than the digital scopes are, because the digital scopes are going to have a lot of things that are going to be controlled through menus. Okay, so you touch the channel 1 button and all the vertical controls are going to show up on the screen. You touch the horizontal button, the horizontal controls come up on the screen. So you'll find that you generally sometimes not even have a knob per input. You might have one set of knobs and then you select the input on the screen. So the interfaces can vary quite a bit on the digital scopes. So the question I get asked a lot, especially in an amateur radio world, well, an analog or digital scope, which is better? Okay, which one should I get? Okay. In many cases, a digital scope is better. Automatic measurements, acquiring into memory, all that kind of stuff. They're lighter weight, they're smaller, they're going to be more reliable because they're newer. A lot of those things make them better. But for a lot of the RF work that we do, especially if you want to look at like the RF envelope of a signal or something like that, the analog scope is better. Okay, here's looking at like a single sideband RF envelope of one of my radios here on an analog scope. And everything you can see the intensity grade to things get kind of dimmer and brighter. You can get an idea of modulation and things like that. On a digital scope, it's very bland. It isn't quite as informative in my mind. So, and also you can get into situations where the RF gets undersampled and you can alias signals. They're not going to update as fast and as lively because it's processing all this data. So, us electrical engineers got away with analog scopes for 40, 50 years before digital scopes came along. So you certainly can get away with an analog scope, and you can find them sometimes these days even for free, because people are getting rid of them and getting the digital scopes. So if you don't have one and you want to get into a scope, look for someone giving away or practically giving away an analog scope to start with. A couple of setup tips. Think about how big of a signal you're going to be looking at and set your voltage per division as needed, right? Volts per division says how many volts applied to the input is going to move one division on the screen. You generally have got 8 or 10 divisions vertically. So think about what you want to set that for. Make sure you account for the 10x probes. If you're plugging in a 10x probe, make sure that you multiply that value by 10. Some scopes will automatically do that. They'll sense the 10x probes and fix that, but depends on your scope. Consider whether you need to AC or DC couple, depending on what you're looking at. And when all else fails, use the beam find to find that signal that might be buried off the top or bottom of the screen. Trigger settings, internal, auto, AC or DC, edge, mid-level is generally all you need to do. And on the old Tektronix scopes, if you pick up an old Tek scope with all the little lever controls and lever switches, generally all those switches move to the top. Okay, auto triggering, AC coupling, move all the switches to the top position is kind of the most common starting point. And a lot of other scope makers kind of followed that same logic. And then horizontal, start fast and adjust down, especially on the digital scopes, because you might be aliasing if you start too slow. Okay, so start it up at, a microsecond of division or faster, and then bring it down depending on what you're looking at. Okay. So obviously, any questions you have here, my YouTube channel's there. I probably have a third of my videos on my channel that have to do with oscilloscopes. So there's a lot of information you can grab there. A couple other quick little things we'll take a look at. How could we use the scopes in a ham shack? Transmit signal monitoring. Look for flat topping, modulation checks. Make sure you've got your PSK 31 adjusted properly. You can do amplifier linearity measurements. You can do it with a little pulse generator. Do a TDR to look at your coax and obviously circuit troubleshooting and repair and that type of thing. So with monitoring your transmit, you can buy or build a little RF sampler. It could be a simple resistive or capacitive sampler. You can do a demodulated check to do like XY linear measurements. Looking at the RF envelope, you might want to look to see if you're flat topping at all. Look at PSK envelopes. Actually measure AM modulation depth. It's a very simple equation here to do that. Doing analysis for coax, you can actually apply a fast pulse to the input of the coax and scope what's going on there. And then look at how long it takes the signal to reflect back off the end of the line and then you can calculate out what the length of the coax is. Maybe do a distance to fault measurement type of thing. Okay, this is a little pulse generator that I built using a little logic gate, and makes a very fast, few nanosecond edge, about a 2 nanosecond rise time to ring out some cables. You can even measure capacitors and inductors using a similar little pulse generator. You can make some measurements of capacitors and inductors with a scope. I've got a couple of videos on this, so I won't go into the details here. These are all notes that are from the video that I did, but some real easy way to make some capacitor and inductor measurements. So anyway, that's what I had. Let me just stop the sharing here, and haven't taken a look at the chat to see if there was any questions that came along here, and I blasted through that a whole lot faster than I normally would when I'm doing the presentation in front of people. But I just want to wet your whistle a little bit, make you not afraid of the scopes. Don't worry about letting the smoke out of it. You might have let the smoke out of one of your circuits. You wanted to see what's going on, and to me, I always say that's a good thing, because you'll learn a whole lot more from your mistakes than you do from your successes. So let the smoke out and go play. But anyway, thanks, and good thing that we don't have audio on everybody, because I'd have to listen to everybody snoring. But I think we're good.
Well, over the years, I've used the scope for a number of things. Nowhere near as extensive as you, or have the knowledge to do things you do, but it's a good little thing just to do simple measurements, like you said, voltage. Another thing, I know you got a video, I've seen it. It's on a curve tracer. It's just a little box you can build up. Attached to a scope.
The one that I built up there is called the Octopus. And it basically is a very simple little one trace curve tracer that you can use for troubleshooting and things like that.
And I built one of those back many years ago, and it was a wonderful piece of test equipment. Just put that probe on a transistor, and just by the shape that you see on the scope, you could tell if it's open or shorted. I mean, you could check diodes, resistors, transistors, and all those kind of things. So it really helped a whole lot. I guess to some extent, I was able to even test transistors in the circuit. I know that's probably not the greatest test, but it would still give you a pretty good indication.
With that little curve tracer, what you're looking for is, if you've got a known good circuit and a bad one, you can compare what the traces look like between the spots and say, okay, the trace that I get at this node doesn't look like it does on the good circuit, so the problem must be in this area somewhere. So it is a nice way to do quick circuit checks. And in fact, there was a company called Huntron, I think, that probably still makes, called the Huntron Tracker, and all it was a commercial version of that simple little Octopus curve tracer circuit. And it was used by, when I was in high school, I worked in a TV repair shop, and we used one there to buzz out circuits and things like that to find faults.
Just looking for the Huntron, because I used to have one and used to use one years ago.
Yeah. Dwayne, you said you used to use one in aerospace too, right?
And you're the TekTips expert there, and you know what? There are a lot of Tektronix, even at the Hamfest. You go to Dayton, man, you see thousands of Tektronix scopes there, like you were talking about. People selling them cheaper or getting rid of them, and you can still pay high dollar for some Tektronix scopes there too. You know.
Yep.
Yeah, my go-to scope here is a 475.
There you go. A nice 200 megahertz benchtop scope. Very nice.
Yeah.
I was in the Corps, we had Hewlett Packard was
The HPs,
And,
Yeah.
I remember in school that we used to screw with people by taking a waveguide magnet, sticking it under them when they weren't looking. And it would
Yeah.
make the wave signal dip, or it'll actually make it curve sometimes, depending on how strong a magnet you put under it.
Oh yeah, we had when I was in high school, we had an electronics elective that I took. In fact, the electronics teacher there was kind of my mentor in ham radio. But we had an old, like a Tech 556 or something, or 545 scope, which is a big rack-mounted scope with plug-ins and had a whole sea of knobs on it. And of course, we were in high school, we didn't know how to use it, and even the teacher wasn't real familiar with how to do it, and we always screw around with them and get the knobs all messed up. So when he went to use it, it took him a half an hour to figure out how to get us trace back up on the screen again. So
One thing I liked about the Hewlett Packard is they had the little clip on there that had the 1 kilohertz square wave signal that was always present. You could, if you got off, you could always clip onto that and set it up so that it was exactly right.
And that's actually the signal that you use to do the proper compensation on the 10x probes. That's why it's there. So most scopes will have that.
All right. Well, hey, thanks for sharing that with us tonight. If there's any questions, guys, send your questions to Alan, and he'll get you an answer.
Yeah,
and looking forward to see what we're going to talk about next week on TekTips. I don't know yet. Well, as soon as Alan picks something out, we'll know.
All right, I'll figure it out between now and next week.
Yeah. All right. All right. Very
Alan,
good.
quick comment. I just looked up Huntron, and they are still in business selling brand new versions.
How about that?
2020. So
Really?
they've added new features, and it looks kind of interesting.
I never heard of that brand. You know, back in the days I growing up, you know, we had the Heathkit and the Ico, and you know, a few of the others like it. I've never heard that brand.
You can, if you look around, you can find Huntron trackers about the 1985 versions or so for under $25. So
Yeah.
they're kind of handy to have around.
Very good.
All right, well, let's talk real quick while we have a little time left. People have been asking me about, you know, the next launch for the balloon there, and of course we've got Bill Brown, our balloon expert, with us tonight, and he's going to tell us why we're getting into a good season to launch. You know, we've had some pretty bad weather that we've been into over the past couple months. So, Bill, is things getting better now to start flying again?
Starting to get good. In fact, your last launch, you launched right into an incredible jet stream, and we're going over 150 miles an hour at times. So things are starting to ramp up. The rule of thumb when you want to send a pico balloon around the world is to launch in a month that has an R in it. And October is the start of that season, and September really, but it gets really good in November and the late October timeframe. So they just did one from Huntsville a couple weeks ago, and it got caught in some doldrums over the Canary Islands, but it is now on its way. It was last heard in Israel and Jordan about 2 days ago. It should show up in China, and it's doing great. So they're really starting to pick up some speed. So this is a good time to of the year to fly.
I'm noticing balloons are making it around now in about 10 days. I mean, that's pretty fast. You know, our successful flight did 3 revolutions in 72 days. That's over 20 days a revolution. But I'm seeing them now do 10 days, maybe less. But that last flight, we went down. You know, we crossed the ocean in about a day and a half, man. We were moving.
Right. Well,
Yeah.
10 days is pretty speedy, but
Yeah.
as we get into December, January, and February, February really has the highest winds. I've seen them go as high as 220 miles per hour ground speed. So, and you
Yeah.
were going 150 in this last flight that you did.
Yeah.
So,
And you know, we've launched so many, Bill. I can't keep up. Was the last one that went down in did it go? Where did it go down? North Carolina, or I'm confused, Bill. I can't remember. We've done so many. Did the last? No, wait. The last
No,
one. The last one made it to.
Albania.
The last one made it to Europe, didn't it?
You landed in Albania.
That's right. That's right. That's right. Now, did we launch one after that? No.
No.
That was it. That was it.
Albania turns out it used to be a very closed society,
Mm-hmm.
and ham radio was pretty much suppressed to keep information from getting into their country about what the outside world was. But I just saw a really nice website from the Albanian Radio Club, and actually it's got a lot of nice features on it, a lot of neat news about amateur radio. So if you search for the Albanian Radio Club, they've got some neat stuff. So maybe you can get in touch with some of those people. It's only about 10 miles from the capital of Tirana, but it's in kind of the mountainous area. But
Yeah.
it did
Well-
transmit once after it landed, so we know pretty much where it is.
Yeah. I don't expect to get it back. I mean, you know.
Probably won't be back.
I'm still waiting on our Polish friends to relaunch. Man, I don't hear from those guys. Did the government cut their internet off over there?
Well, they've been on quite a bit of lockdown, and then
Yeah.
there's been a resurgence of the COVID, so their gatherings have been limited. I will fire off an email to my friends there and see if
Yeah.
I can follow up
Well,
on
you know, our plan was to just stop for gas, right, and just launch again and make it on around. But because I don't think anybody else has stopped overseas to get gas and then continue. But you know, we've had so much now after that it doesn't mean a lot to us. You know.
I was involved in a neat project this past weekend, week ago Friday. The Smithsonian Institute has a program called STEM in 30 Minutes,
Mm-hmm.
and they do different programs and events for schools across the country. And this time they did it on pico balloons, and so they I sent 10 sky trackers out to the Smithsonian, and they went out to teachers that had ham radio contacts, or the teacher was a ham radio operator.
Uh-huh.
In the case, several of them were. And so they launched 4 from the Washington, D.C. area and Virginia area, and then Utah, Alaska, Washington State, Oregon, and Oklahoma, and also Kansas. And they all streamed it live on the Smithsonian Institute's website. They filmed the launches from the different schools. And most of them didn't survive the day because they went up one day, and 2 of them didn't make it to float, but the other ones did. But then this big hurricane Delta came through and messed up the whole central part of the U.S. And I know they have to time these events. You know, it's hard to change a schedule, but the hurricane tended to wipe out most of them, but 2 of them are still flying.
All right.
One just was heard off the coast of Ireland today, and the other one was last heard over Newfoundland, off the coast of Newfoundland. So we have hope that those 2 will make it across to Europe.
All right. Well, look, we're going to be running out of time here. I do have a video, and I'm going to fast forward through it. We basically did this video for our friend down in, where is he? Colombia, I think it's. You know, he's wanting to learn. He's been talking to you, Bill, about launching one, and he's a little worried. You know, how do I fill the gas and do this and do that? So we just made a little video of what we did. Now, it's not exactly right. Don't try this at home. Bill, I know it. Last week when we talked, I was talking about when we sealed the balloon, we ran a bead across it, and you said run a bead across it. Well, we have just laid the iron flat. But we've been normally running some beads across there. In fact, that's what SBS told us in the beginning, to put a bead across. In fact, I'm not sure about their new sealer. They want you to use a new heat sealer now that's got a little line across it that just, does it. But anyway, I think on the next one we're gonna try to seal it flat, and you'll see what we're talking about here in a minute. So I'm gonna put this video on real quick, and I'll try to pass through it here. Nobody got hurt. We still have our eyebrows. Well, I got a someone watched the video, and boy, did I get told, man, I got told at least 10 times I'm going to get blown up. I got to have the tanks outside and chained to a tree, or they'll turn over and I'll blow up. The flash on the camera, I'm going to blow up. He gave me a bunch of reasons, but luckily we didn't get blown up. But I want to show you kind of the process of taking an SBS balloon and what we went through. This is not the exact way to do it. Bill probably will have some suggestions on how to do it better. So I'm going to run this real quick, and I'll try to fast forward through it, but just hit the highlights here. So let me find this, and here we go. Yeah. We didn't get any parchment paper that time, but I got some parchment paper. So this is let's see if my audio is working. This is how an SBS comes to you, all rolled up. They say don't touch it. Wear gloves, don't touch it. Well, we don't follow those instructions. That's probably why we're not that successful. That wasn't good. That's not good. All right. So basically that's what an SBS looks like.
You want a cardboard here or not? You may be able to see it better. Okay. Here's the end right here. I was going to say, I'm looking at the end of it.
It's about 7 feet long. When blown up, it's about maybe a couple feet in diameter.
The camera just suddenly decided to go, well,
It's supposed to be very fragile. I found, Bill, that it's not as fragile maybe as people say it really is. And occasionally we put too much hydrogen in, and we have to squeeze a little bit out.
All right, you were saying that, what do they do with it too?
that don't sound right.
All right, so in the video, okay, so here's our SBS balloon. Here's the filler tube right here, and we're going to put the hydrogen through here, and this is what we will heat seal here, and we'll tie onto this. See me running and try to keep up, okay?
You need a bigger table, Tom.
Yeah, I know, but we just have to do this is an amateur operation.
I can't find it's in there. Hang on just a minute.
Ed's not a ham, but he's been a friend of mine a long time, and he's the one that brings the gas over, and we launch these together.
Yeah, just keep pushing it.
Yeah, we'll be very careful getting this in there. Even the plastic tube that we put in there is a little dangerous. It could tear the balloon, so you got to be very careful in putting the plastic tube in there.
Okay, right.
Let's see.
You don't have to stick it all the way in either.
Yeah, right. So there we are. We're putting a little gas in. And let's see, we're going to go a little bit further here. Okay, we got a little gas in it there.
Tom, did you fold it in half and tape it together?
I never have. No, I never have done that. I keep seeing that, but we've never done it like that. Now, believe it or not, I can look at that right now and tell you we have too much lift in there, too much hydrogen. Yeah. So we're going to squeeze a little bit of it out.
If you fold it in half with the bottom half where you're plating, once it lifts off the table, you're just about there.
Yeah, and that's what we watched for when it just lifted off, but boy, it lifted fast. And so I'm going to, there we are weighing it. At first I had a weight that's set for the weight we wanted to go to, 20.
12.
Okay, the payload was 20. And 20 and a half, and we wanted 6 and a half, so I had a 27 weight there, but we finally did away with the weight, and we just hooked it on there and measured the minus 27. So let me take that weight off.
Prove it. zero it. Let me
I
check this
found
out.
nice hook weights,
Yeah.
the 50
This will
gram
give us
weights
an
with
actual
the hook
lift
on
of the
them.
balloon right here.
They were
Up
about
to zero.
$4 or $5 a
27.
piece, and I've been using those.
So you're 32.
Yeah.
Okay.
So
not
we're
too
gonna
far
hook it
off.
on a paper
So we
clip.
got a little bit too much gas.
Oh, we got a little bit too much. That's our life story,
you
man.
put
We
the
got
weight on it,
32 in here.
No,
We need
but-
27.
But we've got to be at 27.
All right. So here we go. This is the do not do at home part. And if Ron out at SBS sees this, he'll be telling us how
You'd be wearing something like cotton
how
gloves.
we're bad. And I agree with him, but look, we bought the balloon so we can do what we want to with it. So we're going to squeeze a little out.
Less than an air pressure though, because at altitude this will be full.
Yeah, we're going to squeeze a little out.
No, don't bother.
And Ed has it in his ear. He's putting hydrogen in his ear right now.
2 grams.
So he's trying to see if any's coming out of the tube. Okay. All right, so yeah, it's a little bit coming out. Boy, you almost can't tell it's coming out. All right, so let me fast forward here.
27.432.
So we're going to measure again. We're looking for 27 lift.
7.4 grams.
All right. A little more out.
We're looking for 27 lift. I think we're short, maybe 1 gram. So we're gonna. Well, let's see. Must have been too much. Here we go. Here we go.
Faster on a slide rule.
What we got, Ed?
26.8.
26.8. We
26.6.
no wait. 26 point.
26 point.
We got to wait for it to stop there.
You're 0.3 short.
What was that? 3.3?
You
So we
don't know.
wanted
He's
about
got 2 now.
27 in there. So we're going to put a little bit more in. So watch this. We needed just about 1 gram. So
Why am I trying to be
he
quiet
does
here?
4 little bitty squirts. And it's amazing how much goes in with a little bitty squirt. So watch this.
Ready? Just a shot in there.
Yes, I got a little more.
Oh, that's
4
okay,
little
one
bitty
gram
squirts.
per-
And he added more than 1 gram of lift.
All right.
That's,
we got it.
that's
Professional.
what it takes.
Yeah, don't try this at home. All right.
Doesn't take much.
300 and we're
What? 42 ounces?
yeah we're at 28. 28.5. It's about the average. It's going to 8.3.
25.
I think, yeah, and we took a little out. Those 4 little bitty squirts were too much, so we took a little out again.
All right. The thing that she's up here.
So now we've got it down to what we want, about 27 something. And we're going to heat seal it. Bill, I'll show you how we normally have heat sealed.
27.38.
How we normally
Hot
have heat
iron
sealed.
now.
All right, who's the slowest runner here?
Yeah, you just have to be. Well, no.
I need to know who to trip.
Yeah. Okay. So you can use a regular a clothing iron to do this, but we bought an iron to do it. Yet I'm going to try to get the first one up here kind of high. What about this? So we put some parchment paper over it, and we're going to run a bead across it, and hopefully it'll melt the balloon. So here we go.
Apparently, you don't need the parchment paper with this new heat sealer method.
Really? Yeah. Well, I like the parchment paper. I was always afraid I was going to melt through a $160 balloon, you know.
Yep.
And here's what we do here. Just we run a bead across like this. And it actually looks like it seals pretty good, actually. But what we do, we normally will run about 4 of those across. We have done it flat before, and I think in addition to our bead, we probably will next time flatten out the whole thing, I think. So there we are running a bead across it. Let's see.
How's that?
Fast forward a little bit.
Let me.
You can see we ran a couple across there.
Okay. Yeah, I think last time we put.
All right, I've got some of this tape, Bill, I was talking to you about. What we're going to do, just to reinforce that just a little bit, to keep the string from tearing the balloon material. What we normally do is, it's coming. There we go. We're going to put a little piece of tape under it. And we're going to fold it over. And then we're going to punch a hole through that, and that tape should help reinforce the balloon. This is just some special. Okay, and we should be sealed above it where it doesn't leak. Let's see, did I get the? Okay, here we go. We're going to punch a hole in it.
And a hole punch is for the payload.
And then we're going to tie the payload right there. Wow. All right. And then of course we're just going to tie our string that holds our tracker. What we're going to do, we're going to take this and the tracker line. We're going to take the tracker line and this line. We're going to tie them together, and we're just going to let it. All right. Because I live really There's the tracker in the box. Oh, let's see. And here we are out at the field. We did a wind test. We always drop a balloon in the air for a wind test.
Not bad, not bad. Not bad at all.
You know, we did not add the weight of that tape in. That little piece of tape actually was probably about at least 1/4 of a gram. It doesn't take much tape to heat the box. Yeah, what was that? Yeah. Well,
I bet it was at least half a gram.
I think it might have been up to a half. Yeah.
Yeah, is that the?
This is the top one.
All right, and then okay. We just hook that one up. You sure?
It doesn't take much to get a half a gram or a gram. Just hold on to it, okay?
I got it.
So what we're going to do, we're going to put it together here.
This is in here. Okay, now let me see what.
Now our field has a lot of tall grass with those sticker things on it, and it's really easy to get your antenna lines stuck.
Like I'm doing. Try to hold the bottom.
So hey, I noticed they just mowed that entire field this week. So we should be good. So we're getting ready to launch here. We do have a drone flying around out there. It's going to try to get a picture with the drone, and but that's in a different video. So there was our test balloon. All right, we're getting ready to, and Glenn just took a bug off of me. The balloon looks pretty empty actually, and that's what a lot of people don't understand, how it is so, so empty. There's our drone out there flying around.
I need to get downwind, upwind for you.
Also, we learned the way to launch this big balloon here is I've got to get upwind from Ed. Ed's going to be holding the tracker. So when I release the balloon, it's going to go basically up over his head. We've tried it before with the balloon downwind, and the wind just makes the balloon go level, which is not good for takeoff. But you'll see here the balloon's going to go pretty much straight up, and it's just going to lift the tracker out of Ed's hand. So here we go.
Gotcha. We got a little bit of on the antenna wire there. I'm gonna walk back. It looks like it's tangled.
So we got a nice sunny day to launch. Here we go. 5, 4, 3, 2, 1. Here we go.
Doesn't take more than a couple mile-an-hour wind to.
Yeah. But we've got a lot of open space here. We've never really needed it. Okay, there we go. It's going up. The line's tightening, and then Ed just lets the little tracker out of his hand, and it just goes right up with it. And there we go. Pretty successful launch.
Good luck.
And Bill, there's a I don't know if, yeah, that's a good shot here. There's a contrail or some clouds up there, and I looked up there once. I thought the balloon had exploded because I want you to see this. Let me see if I can find it here. Yeah, do you see that right there? It looks like smoke above it.
Yeah.
And it gets worse, but that's a cloud behind it there. Let's see if we can.
So you just leave the antenna wire stuck in the weeds, and it just pulls the antenna wire out?
No. We hold it above the weeds. We don't let it. Even the bottom one, we don't let it get in the weeds. If it gets in the weeds, it can be bad news. Bad news. All right, so that's pretty much that flight. It went to Albania, and You know, we're hoping to launch 20 maybe next week, maybe about Tuesday. There's 20 there kind of laying out in the bushes there, getting a little sun today and transmitting. It's just, we built it on a piece of styrofoam, and Bill, what I did, I cut 2 squares out from under the solar panels to reduce that weight. And 26 point, what is that? What is that you show me, Bill?
That's a scale that costs $14 on Amazon, and it does a great job. It's 220 grams, and it comes with a 100-gram weight that you can use for your chair weight.
Oh, that's cool. Oh, let me get back here. Okay.
This a hook weight I found for Ajax sells this, but it's a little weight that has a hook built onto it, so you don't have to use a paper clip. It's best to put a little excess weight to be at the mid-range of your scale or towards the upper end of your scale before you measure the lift. If you try and measure lift directly, if I taped a hook onto this, it's not as accurate going negative from a 0.
Yeah.
So you want a little weight on it.
Well, and that's why I actually had built a weight and designed it to be exactly, the weight we wanted plus the lift to put on there. That way we were gonna pull it up to 0, but it ended up we actually went the other way with it. But anyway, we hope to launch next week. Now, Bill, I got a question for you. I got JT9 turned on. I hear 2 50-second transmissions, but on my that what? I can't copy it.
During your last flight, it was about 3 dB less signal level than Whisper, which is exactly what you'd expect. I copied it down to about minus 27 dB.
Well, I guess what I'm saying is I've got it transmitting here. I'm testing. It's picking up fine on Whisper, but when I flip over to JT9, I never pick it up. But it is transmitting.
If you click on the frequency scale, it transmits around 1290 hertz. So you have to move the frequency bar
over
to that part of the spectrum where that is.
So so that's my problem. I thought something's going wrong with WSJT. It's just not picking it up. I see nothing there. So I'll look at that. Yeah, is that new? That's the new oscilloscope, isn't it?
Yeah, that's the one they recommended. I went and got one.
So how wide of a thing?
It's pretty good. It's 8 inches. It's
how wide is the actual seal? Is it like pretty narrow?
Oh, yeah. It's, let's see. It might say here.
I mean, is it like 1/8 of an inch or something like that? Maybe about like what we were doing with the iron.
The ceiling width is only 0.078 inches. So not even 1/10 of an inch wide.
Yeah.
And it can do up to 7.8 inches long.
Yeah. Well, we're cheap here, so we didn't want to buy another iron. So we're going to use the iron we've got.
They recommend a $80 scale on their instructions, where this $14 scale works just as well, and it comes with a weight. So this is a great little scale.
Right.
And it's super accurate. I've calibrated it with lab weights to check it, and it's very accurate across the range.
All right, well, guys, so we've gone over in the show tonight. I'm going to go ahead. We're going to end the show. Thanks, everybody, for tuning in tonight. And again, if you're listening out there on WBCQ on 6160, we'd like to hear from you. This is a ham radio show. We're on every Tuesday night at this time. Send us an email if you're hearing us to tom@w5kub.com, tom@w5kub.com. Send us an email, let us know where you are, and you can always join us by going to w5kub.com if you have internet access here. Thanks for watching tonight. Looking forward to the show next week, and everybody be safe, and we'll see you next week.